so that we record all of this. There we go, recording has started. So guys, what we're going to do tonight is we're just going to finish up logistic regression. We've done most of it, and you guys did really well last week by sticking around so late. So maybe tonight we'll finish a little bit early to reward you for the suffering last week. And maybe we can wrap logistic regression so that you feel comfortable with it. But as always, if there's things freaking you out, I'm happy to make a video. Did you guys watch the videos or find the videos for OLS? Oh, no, Mansrina, what are you saying? For the shrinkage models for lasso, ridge, and elastic net. Did that help you understand? So guys, I showed you the calculations just so that you can see those things shrinking, but you don't have to ever calculate them. Those calculations are just for understanding. Okay. All right, so let's look at this assignment and go through it one more time so you can all be comfortable. All right, so first of all, guys, no one is out to get you. Just remember that. We realize that this is a statistics module at postgrad level, and that for a lot of you, maybe you didn't do this level of math, or math was a very long time ago, or math scared the crap out of you. So no one is going to mark you harsh. And just so you can understand some of the rules with marking is we are more likely to reach out to you to ask you if we're unsure than just to mark you down. So when the marking happens, you will see that messages will pop up on the WhatsApp group. It will say, hey, Tando, can you please contact me? And then we'll be like, Tando, we can't find this. Where is it? Or so this is postgrad, you guys. It's not undergrad. The way things are marked, the way things are handled is different. Okay, so I need you to just breathe and know, like, if you submitted something in a weird place, we're not just going to give you 0. We are going to reach out and ask you. And then if you've done something like didn't submit it, then we have to give you 0. But we're always going to give you the benefit of the doubt first. Okay, so let's look at this assessment. Okay, so question 1 is theory. Do you guys have any questions on the theory section? Because it's just the nominal, ordinal, and interval scales and what happens on statistics. If you apply statistical methods to them, define and contrast training error was test error. And then you guys will do GAMS next week, so you can answer that question next week. You should, after watching those videos for lasso and ridge regression, be quite comfortable with the bias and variance trade-off. And I've done a whole video series for you on lasso and ridge. So are there any questions on the theory section? I'm going to show the chat. When is the assignment due? Yeah, Mr. Kuchler? Your hand is up. Maybe I'm butchering your name. Mr. Kuchler Bulayane? Do you have a question, or was that just a... Okay. Type in the chat if you have a question, or just interrupt me. Okay. Oh, was that a boo-boo hand? Okay, it's due the 30th of March. Okay. So you guys, this assessment doesn't take long. Okay, I hope you've noticed.
Hello, can you hear me?
Yes, I can hear you. What's your question?
I'm sorry. My internet is acting up today. Just on the theory section, let's say it says 5 months, 5 marks. Do you usually prefer maybe if you can list maybe 5 points, or you want paragraph type of answering? Thank you.
Okay, so nobody wants paragraphs. Okay, this is the numeracy course for a reason. You type the answer in enough detail. So, like for instance, if they're going to ask you what is linear regression, you're not going to type linear regression is y equals mx plus b. You're going to say linear regression is where we try to predict a variable called y by using the equation of a line, which is mx m times x plus b, and this is how you implement it. So that's the level of detail, but no, it's not a marker point, hey? So you don't have to write deep paragraphs. Just make sure you get your point across and clearly. And the thing is, you can write in 4 lines, and another person can write in 10 lines. It's the same thing, the same mark will be given. So there's no preference for lengthy answers. There's preference for clear answers that show that you understand the concept. My best advice to you guys is if it's something like linear regression or where they're asking you ridge and lasso, touch on all the points. So start on the, almost I'll give you the answer there. Touch on all the points about the thing. So again, with linear regression, touch on it is an algorithm used for prediction. Describe the formula, describe how the formula is applied, describe the data that is used on and why. And then you're done. Did that help you?
Yes, yes. Thank you.
Oh, no
A lot.
problem.
Thank you.
Okay. Kamugelu,
Good evening.
good evening.
I just wanted to ask, so is it 30th March to 2nd April or like strictly 30th March at midnight, meaning the
Okay.
1st of April?
So what is the date range given? Is it the 30th March to the 2nd of April? What's the date range given to you in the past?
30 March to 2nd April.
Okay, you guys, your assessments work like this. You can submit at any time between the 30th of March and the 2nd of April. Hey,
Yes, yes.
you can submit from, that is flexible submission dates, because we realize you have jobs, you have lives, you have children, you have things that happen, in-laws, cats. So that's why there's a week space for you to submit, and the cutoff is, yeah, the cutoff is the last day, and I'm not sure about the time. I think it's 12 p.m., 12 o'clock at night, or it might be 9 o'clock at night. They shift that all the time. But the
Okay.
last day. So the 30th is the first, and then say the 2nd is the last.
All right.
Okay. Alizwe? Aliziwe.
Yes, hi. I had a question with regards to that date range. If I submit on the 30th of March and then again 1st of April, are you going to take the 1st of April one or the 30th of March one?
We always take the latest submission, unless you put it, there's a place where you can type. So you can go like, oh, you actually please mark there. You'll see the system will mark you submission 1, submission 2, submission 3, submission 4. So we will always mark the latest submission, but you can also make a note on the system going like, oh, I made a boo-boo here, please mark submission 2. So give information. Okay, does that help?
Okay. Yes, thank you so much.
Yes. Okay. Right, you all sorted for the theory section. You can do the theory section in a Word document and upload that separately. You guys, you can type your theory into Excel. There really is no rules. Do what is easier for you. But the rule is label things so people can find it. Don't make, because I'm not I am a marker on this. I just do linear regression. Don't make the markers' lives hard. You want to be as kind to your marker as possible. So you want to make your stuff as easy to find and mark as possible. Generally, copying and pasting word bits into Excel goes a bit wrong. So just clearly label question 1 theory, question 2 linear regression, whether you do separate sheets or one Excel sheets with tabs, that's up to you. Just be sure that you clearly label things and you make it easy for people to find. Okay. Alrighty. Okay. Now for the linear regression question. So the first thing is they're saying that you have to submit a PDF report containing an executive summary, aim of the study results, interpretation, conclusion, and recommendations. So I've asked Gareth to upload a report template. That's a very detailed report template for PETA, and for the love of Jove, don't do that. But I just wanted you to see the structure that's followed there. So in the case of this one, you're going to say, like, say we had for fish, okay? So the aim of this study was to train a linear regression model that can help us like predict the weight of different species of fish using length 1, length 2, length 3, and height. Okay, that is, we have, your executive summary is just an overview. We have found that the model comes through with an R2 score of 98%, making it super efficient to predict the weight of a fish based on blah, 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 blah. Okay, aim of the study, then you're going to say, okay, next little section, the aim of the study is to build a regressor that is able to predict blah, 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 blah. Your results, what you found, go like, I found this slope, this intercept. And when I use this, I come out with this result, then interpret those results. So, so I got an R squared of 5%. This model is terrible. Then your conclusion says, this is a crap model, don't use it. Recommendation says, maybe train a different model, look at a different data set. This data set might be highly unsuitable. What we're going to look at tonight is the small differences in weight between breams and perches makes things quite difficult. But that's the structure of the report. Okay. and then give your Excel worksheet. So your executive summary is in 5 lines, what you did, why you did it, how you did it, what you learned, and what it means. Then aims of the study is what were you hoping to get done with this regressor. Your results are what are the coefficients that you learned and what are the evaluation scores that you got. Your interpretation is what do those evaluation scores mean, and your conclusion and recommendations is, can I use this module? Is it ready for deployment in a corporate setting, or is this model not ready, and here is why, and this is what I can recommend to fix it. Did that help you guys feel calmer about the report? For you guys, do not zip. That is the only thing we're going to ask, because if you zip, we have to download your files and unzip them, and then we cry bitter tears of sadness down our faces. Okay, because if you don't zip, we can open up files in ARC and mark in ARC. If you zip, we have to download then, and there is 200 of you. So if I have to download 200 zip files, I'm going to drink all the wine in my cupboard and give you terrible marks. No, I'm teasing. But be careful, don't zip anything. Okay, thank you, basically, for asking that question. Otherwise, I wouldn't have told you. Just upload your files. Okay. Right. So, okay. So here is your thingy. It is hypothesized that a student's performance we did this example. A student's performance in an examination depends on the number of hours spent studying and the number of parts examination papers reviewed. You are provided a data set containing the following features: hours studying, preparation, exams, and marks. Okay, compute the Peirce's correlation between hours studying and marks. So you're going to go into Excel and compute that with the correl function. That is 5 marks, again, for JAM. And then you must just tell us what that correlation means. So don't just say the correlation is 0.9. So you're going to say the correlation is 0.9, which indicates a strong positive correlation, meaning as study hours increase, so do marks. That's what they mean. Interpret the strength and direction of the relationship. So compute it, interpret the strength and direction of the relationship. Then, using Excel, fit a multiple regression model to predict marks using both predictors. So what you're then going to do is just apply multiple linear regression, go and find your slope and your intercept. You know that you're allowed to find that with the solver. You don't have to go manually calculate them, and then just go do your OLS the way we've done in Excel all along. Drag it down the column, and then you can see. Okay, and then you're going to give your model is going to be marks equals your B1, your B2. Okay, so go work out those coefficients and apply them. All right. Okay, the regression output of the model is partially shown below. So that you can see your R squared. Oh, this is a poofy model. But here is the outcomes, and here's where the boo-boo lies. And remember what I said, we'll accept both. Okay, so identify the values of A, B, and C from your regression model. So you're just going to give us the intercept, the slope for preparation exams taken, and the p-value for C. Okay, just straight up like that. All right. Why you get so many marks for that, I don't know. Then discuss the key assumptions of multiple linear regression. Comment on how well the model satisfies these assumptions based on residual plots. The key assumption of that, if this is what we check for it every time with that correlation feature, and we show that little plot and we want to see a thing. Discuss that. Then talk about this R squared or the adjusted R squared. They'll be very different, very slightly different. Talk about that score and what does it say about how good your model is and how well your model explains things. And then they're going to ask you, is B statistically significant at the 5% level? Justify your answer using the p-value or confidence interval. So this Gareth did with you guys on Saturday, but you can also find your p-values over here. Okay, but Gareth showed you also how to calculate your p-value, and then you're going to use the model to predict the mark of a student. Then you're done with that. So, where are you guys? I almost showed you the rubric for the practicum for the master students. Do you have any questions on linear regression? And then I'm going to look at the questions in the chat. Yes, Andrin.
just a question in terms of the formatting. From what I'm understanding, as long as we are submitting multiple submissions that have the answers to the questions, everything will be okay. But is there no set format or anything like that we should be following? Like we have to answer question 2 on like this document, or we have to do this on this document, or is it just as long as the answers are there, that's all that matters, and as long as it's clearly indicated?
As long as the answers are there and it's clearly indicated, it's all that matters. My advice is do your theory in a Word document, do all your calculations in an Excel document. Yeah, you can have the report and the theory in the same document as long as they are clearly marked. That's absolutely fine. Yes, disclose AI. You reference your AI, disclose your AI use, and you will going to have to give us they might ask you for the prompt. Hey, they might ask you, because in ChatGPT, you can actually share the chat. So they might ask you for the chat. Okay. All right, Nelson.
Hi, good evening.
Good evening, Nelson.
Since we are submitting multiple or rather different kinds of documents, Excel and all of that, I need to understand, are we gonna run them all through Turnitin, or what's the process there?
You actually don't decide what runs to Turnitin. Turnitin decides what runs to Turnitin. So the assessment is set up to run Turnitin or not. Look, and sometimes, you guys, sometimes they make numeracy boo-boos, okay? And then we don't freak out. So you know that you guys, you are all going to have, if this runs Turnitin, and we have gone to the ask people so many times and gone like, the answer to the sum is the answer to a sum, and all the students should get the same answer, because if they don't, we've kind of failed in our job. So Turnitin for this is kind of doof. Lasso is lasso, and lasso is described how lasso is described. So if you see a Turnitin report, and it shows massive, and it especially shows to other students, we are human beings marking, and we will be like, of course, all of the students are getting the same because the answers are the same. So don't worry about Turnitin. I don't even think it is applied to this. If it is applied, you only worry about your theory for Turnitin, but you don't worry that it says you have similar answers to other students, and you worry if it shows you've copied and pasted from a web source. That's it. Did that help?
Yes, thank you.
Okay, Mr. Kuchle?
Yes, sorry, it's me again. My worry now, let me ask it this way. Have you ever had problems with maybe students complaining whether they cannot upload? Because if we're not zipping and submitting multiple files, isn't there a maximum size of all the documents, or is open? We can.
It's
You've
open.
never
You
had
can
a problem.
No, we've never had a problem with that. Never whatsoever. Okay. I will actually take a screenshot of a good submission for you guys and upload it to the chat. Right. Okay. So that you can see it. I'll take a screenshot of a good submission after class and upload it to the WhatsApp group. And a good submission was a theory Word document they just labeled. I'll find one where they've labeled their stuff nicely, and I wasn't like, where's your stuff? Okay. So in the regression question, there's a boo-boo. Okay. So I think this is B, our study that causes the problem. B is preparation of exams taken. Okay, we can see that, but we will mark with the error if anybody makes the error. Okay, the last one is KNN, question 3. So somebody asked a question through Nadia, and then she put it on Teams saying, what if there's an exact flower? You guys, that's highly probable. That's not an error in the assessment. It is highly probable that there will be an exact flower in your data set, and then you just a lucky score for you and move on. Okay, so you are given the following data set, KNN iris data set. So you guys, they're just like giving you marks for jam, yeah. Okay, containing features of sepal length, sepal width, petal length, petal width. This is a new test flower, and I think this exact test flower exists in the data set, and statistically that's probable, so don't worry about that if you see that. Okay, compute the Euclidean distance, and then they even give you the formula. Okay. Then sort the training data by distance and identify the 3 nearest neighbors, which is exactly how you guys did it with Nadia on Excel, because that's my sheet. Determine the most frequent class. And then what will happen if you increase K to 5. And that's it. That's the entire assessment. It's really not that daunting anymore, is it? Or are you still scared? How are you guys feeling? Can you show a reaction on the screen like we are fine, we want to die, we know we can do this? Okay.
Just one question from my side.
Sure,
I had
please ask.
Tenet. I think it's Tenet. Well, how do you access that now?
The what?
I think somebody have mentioned that
Turn it in.
with the summit funded.
Okay, hold on. Let's go here. Just give me 5 seconds to find my bearings. Let's go at group 1.
May as well share the memo there, you know. Just
I can, yeah. I told you guys, it's going to take a lot of wine for you to share that memo. Okay, I'm going to change my view to student view. I'm just going to remember how to do that view as student. Okay, so this is what you guys see.
Are you a mellow kind of girl, or what's going on here?
I'm a really what is it that I have friends who are from the Cape and they say that I drink commoners wine. I'm a Cape South kind of girl. I really like speed, and there's wine called Chocolate Block with which you cannot go wrong, but you're going to have to buy me enough wine to sell to support my family for the rest of my life because I lose my job and I have a teenager who likes cotton on, so you're going to have to provide. Okay. All right, so I wonder if I can show you guys submitting in my view. Yeah, she's not cheap, that child, nay? So be careful. Let's just go here. Okay. So you're going to go to formative 1. I can't see that. Why can I not see that? Lord only knows. But when you submit, it runs it through Turnitin by itself, I believe. Is there one of you that's willing to share your screen and just quickly go into that assessment?
So
I'm seeing the same thing that you are seeing.
That's the same view we have. I think it might open for submissions on the
Yeah,
first.
it's not open yet.
Is that the standard procedure, or?
Yeah, it is the standard procedure.
Right.
But let me also just ask about that. But let me show you on a different course then. I'm going to go into the master's course. Okay, so let me show you there what happens. Oh, man.
So is your threshold 15% or is lower?
Threshold for plagiarism.
Turn
For
it
Turnitin, the
yes.
threshold's 20%.
Oh, okay, that's pretty generous.
Serena,
Yes.
if you go to assessments and
Can
then
I-
click on
can I
assignment
assist?
1, then
There we
So
go.
basically, oh yeah.
Okay. Don't judge a lady in her old ways. Okay, but somebody else assist because I don't submit assignments. So
Basically, when you submit,
yeah,
you click submit, and then it takes a bit of time evaluating your Turnitin score, and then you only be able to see the actual score after like a few minutes.
yes, and you don't have a choice of putting it through Turnitin. They decide if it goes through Turnitin. But Turnitin is not a plagiarism checker, you guys. It is just a similarity checker. A human person will be marking. Yes, Mr. Kuchle?
Yes, I wanted to assist, but you'll correct me if I'm wrong. I don't know who just spoke now. They're correct. So as you submit, it will give you the percentage of AI detection. So if it's above 20%, it will give you there. So I'm sure you will have another opportunity to withdraw that and work on it and submit again. So
Absolutely, yeah.
you'll only be flagged if it's above 22%, 20%, and you leave it like that. Then there you've got nobody to blame, but it's there to assist, not to police. Thank you.
100%, nothing we do is to police. And just know, you guys, I can tell you now, if they have by accident put Turnitin on the submission, because, you know, we are the Faculty of Science is the only place where we teach numeracy. And in the institution, there is humanities, law. Okay, there's some numeracy and commerce, but they pretend. No, don't know there's commerce people here. I take it back. You do quants, okay? You do some stats, but there's humanities, there's law, there's the weird psych people, there's water management. None of them have numerical subjects. So what happens is they just bulk assign, turn it in. And then we just ignore that turn it in report as lecturers, because if you get a different answer in the spreadsheet than what the answer should be, that's not good. So if it shows 100% similarity for all of you for the linear regression answer for the coefficients, all good, because there can only be one answer. So I'll tell you guys this. If you see your Turnitin thing and you freak out, download it, stick it on WhatsApp to me and say, Serena, just have a look, and I'll have a look for you. Okay, well, that alleviate the Turnitin. But as a rule, for numeracy modules, for numeracy modules, not models, we largely ignore the Turnitin score if they have forgotten to take it off. Okay, we will only look at Turnitin for your theory section. And then we also don't look if it's similar between students, because they are short textbook-based answers. We look if you've copied and pasted this from a website. That's all that we look for. Okay. So deep, calm breaths, you guys are going to be okay. All right. Can I now go back into some logistic regression? Remember that if you have questions, put them on the WhatsApp group. Reach out to Nadia. Find me, and we'll happily answer your questions. Okay, I hope you guys are not anxious about the assignments anymore, and you're finding as we're moving through the course that actually it's not that difficult and you're going to be okay. All right. Now, back to logistic regression. So we're just going to do a quick recap, because that just always helps. So why we use logistic regression, how we use logistic regression. Then we're going to jump into that spreadsheet, look at what we've done. We're going to evaluate our logistic regression and move on with our lives. We're going to call it a night. We're all going to go have a good night's sleep. Okay. All right. So we have a bit of a problem when we want to use linear equations to do classification. Okay, sometimes we need to use continuous data, linear data, to classify information, like the weight of a fish. Okay, so they're going to tell us linear equations can stretch from negative infinity to positive infinity, and we need to shove that into a thing that will tell us bream or perch, 1 or 0. So we have to bend that line into this S shape where it will tell us bream or perch. Okay, anything above 0.5 is bream, anything below 0.5 is perch. And it's bounded. It's not going to go higher than 1. It's not going to go lower than 0. So we need a mathematical engine that bends an infinite straight line for that guy into a bounded probability between exactly 0 and 1. And that's why for logistic regression we use sigmoid. So how do we build a logistic regression model then? What is the rules? So number one is we compute a regression score. And we've done that in class many times now. That is your OLS. We convert that regression score to probability, because if you look at this formula, you're going to see that's just sigmoid with extra bits. We're going to put it into probability. And we're actually going to feed sigmoid that linear equation. Then we're going to compute the log likelihood. So we have to check how far we went wrong, and we're going to look per fish, how far we went wrong. And we're going to talk about this tonight, and it's not difficult. Then we sum up all our boo-boos, and we get something known as our MLE, our maximum likelihood estimate, and that is what we optimize for. That is what we want as small as possible, and that is what we, at the end, use gradient descent to go and fix. Okay. Right, so what happens? So we have fishies here. We have fish A, which is like a fat bream. We have fish B, which is a light bream, and we have fish C, which is a tiny perch. So these are fairly easy to go and predict. So we know that 2 is perches, 1 is a bream. This is supervised learning, so we'll always know the answer, whether they are 1 for bream or 0 for perch. Okay, so we have to output as close to 100% certainty that this is a bream or a perch, using only their weight as the input. So this example is single, but remember we also looked at examples of where we use multiple features. Okay, we all know how to compute OLS now. Y equals mx plus b, z equals mx plus b, b0 plus b1, or using the b0, b1 notation for stats, they're all the same. So we're going to come out with a score. Okay, and this score you will see actually moves up and down. The higher the score, the heavier the fish is. Okay, so these are our raw regression scores, and it actually can organize our data for us logically ever. Like higher, the fatty fish has a bigger number, and the baby fish has a smaller number. Okay, however, these are not probabilities. Okay, these are from infinite. Negative infinity to positive infinity is the range that we can have, so it's not going to give us a probability. So we have to move this into a probability. Boom. We shove that sucker into sigmoid. Okay, and here is the sigmoid function. And this function is telling us what is the probability of y being 1 given our linear equation. And we just use the sigmoid function in Excel. So we would like to know the value of y. We take 1 over 1 plus Euler's number to the power of negative our OLS score. Okay. All right. Thus far, is everybody breathing? Nobody is heading for a vomit. Yes, Kat?
Can you go back to your slide for a second?
Yes.
Can you go one slide back?
Yes.
I see here. So just to remind myself, so that weight there, that 0.67, 0.25, etc., that is the distance. Is that the distance from the regression line?
That is your regression score, but yes.
Score, yes.
Yeah, so that is this.
Yeah, the error, like how far it is from the ideal score.
Not yet. That is not your residual. Don't confuse. This is just your original guesstimate. Okay.
Oh, yes. Okay.
Okay.
Thank you.
Okay, no problem. That was a good question to ask. Okay. All right. So what we do is we take this OLS score that we've worked out here, and we did this in the last class. And then we did the built-in formula, and we also coded up the formula ourselves just to see, and we saw came out with pretty much the same results. We take this dude and we feed it to sigmoid. Ooh, first we break our spreadsheet. And we feed it to sigmoid, and it's going to give us a probability. So, whoops. So here we can see that we're feeding all of these values into the sigmoid filter, and it's coming out with these probabilities. However, this model isn't great, and this is why this is a good spreadsheet to teach you guys with, because these are this thing doesn't like to show the difference between breams and okay, we'll get there. It doesn't so like to show the things between breams and perches. Okay. All right, because here, this one we know is a perch, but it has just gone and said bream. Why? Because we've just done one iteration. We have to teach this model mathematically that it's made a mistake. Okay, so how do we teach it this? So we now said, okay, we have gone and calculated our RLS scores. We have whacked that into sigmoid. We have gotten these probabilities, and the model sucks. So now how do we fix it? So they're going to tell you for a tiny perch, the formula spits out 53.2% chance that it is a bream. It's not right. So how do we gradient descent this thing to be better? And that's where we're going to come to the log likelihood. So I want you to forget all the complexity. On the word log likelihood, just remember that the formula you're looking at is called log likelihood. What you as a statistical and mathematical analysis student in honors needs to remember is these things. For logistic regression, we apply log likelihood as our cost or our penalty function. Okay, this is the log likelihood formula. You learn that sucker off by heart, but not even, because you'll always have the formula, and you can always Google for the formula, because you guys don't Google anymore. There is no closed book assessment. You can go look up this formula anytime, nothing wrong with that. But what makes this formula interesting is that it actually only fires parts of the formula when we have a 0 or a 1. So we're going to talk through that now. And then we're going to go apply the formula. But what you're seeing here on the slide is that this formula is actually quite heavily simplified. And what do I mean by that? So this is the instance on this side, if the fish is a bream and if the fish is a perch, what happens? So if a fish is a bream and the value is 1, then the formula is 1 times the log of P, your prediction, that calculation in sigmoid. We're going to go do that, just breathe. Plus 1 minus 1 times the log of 1 minus p. And if you know anything about math, the minute this becomes a 0 and we times, that just falls away. It no longer matters. We're not, that part of the formula isn't going to execute. It's going to times by 0. So we're just going to get the probability of this being a Breen. On the other side, if the answer, if y is 0, then it's 0 times the log of the prediction. Then this part is going to fall out because we've times by 0, and only that part of the formula will trigger. So that's how it knows like very nicely where things fall. So this is nice to know, and this is stuff that you will hear in conversations. Is it going to affect the way you apply this? Not at all. I don't even think your assignment is taking you to the point of applying this. You can actually go take a look. I think your assignment stops just at the point where you can use sigmoid, but I'm not here to teach you to be an assignment and assessment passer. I'm here to teach you to hold your own in the field. So that's nice to know these things. Also remember that after this class, you'll never manually calculate any of this in your life again. Okay. So this is called calculating a penalty. And what we're going to see is the smaller that penalty is, the better the prediction is. The higher the penalty is, the worse the prediction is. Are you guys ready to go and calculate some penalties? This is where you
go ahead.
Yeah, show happy faces. Yeah, we're excited. Okay, so let's go look at Kamagelo, do you have a question?
Oh, just quickly, can you please load that the PowerPoint, this presentation?
On ARC? Did I not put it on ARC?
Well, I don't see it. I don't know.
I will absolutely load it if I didn't put it.
Thank you so much.
Okay, no problem. Thank you to Notebook LLM for making us such a nice presentation. Okay, all right, so let's go do this. Okay, so here is where that has been calculated. Okay, so we're going to go find that formula. We're going to put them next to us here so that we can see what we are doing. Okay, so let's see if this formula is correct. Okay, equals, what is in C2? What value is in C2? It is y. Look at that. Equals y times the log of, that's H2. That's our prediction. Plus 1 minus y, again C2, times the log of 1 minus our prediction. There is your log likelihood calculated. Let's go do it on the next slide. You guys can watch me fall over my own calculations and laugh at me. Okay, so let's go apply this. So how do we apply this? We are going to say equals y times, and then the log is just ln, which returns the normal log, the natural logarithm. So the log of the prediction, got it, plus 1 minus y. And I think I'm stuffing up this formula now, but we'll go see on the other sheet. Times the logarithm of 1 minus the prediction.
Is the 1 minus like a percentage? Whenever I see a 1 minus a digit.
Yes, that's what it's going to take you to. And there is our calculation. Done. So hard. Oh, I did this in the wrong cell. Oops. I also didn't do the nice thing where I'm supposed to do the lessons I had in the last class I have not applied.
Yes, you remember.
I've broken everything. Okay, so this is actually our likelihood formula. Okay, but easy to do. Okay, and then we just go look at classes. So this is our likelihood formula. All right, so what do we do next? Now that we have found this likelihood, we see these little penalties here at the end now. So, okay, and we're going to see this side is when it's positive, the one side of the, now I want to click up and down buttons. Just this side of the formula clicks in, and if it's the negative class, that's in the 0, only that side of the formula clicks in, and that's why we have the higher and lower penalties. Okay, so if we are able to do this, which you can see is not hard at all, we have to go find, okay, so where did we stuff up in total? What is our stuff up in total? So then we go and do this. Okay. I'm going to click on the next tab here called MLE. Oh no, what have I done to that MLE? I've already applied it. Okay, so I'm going to make a copy of this sheet. Okay. Now, where was I? Okay, and we have to go work out our total log likelihood. Okay, to do that, we're going to say equals sum bracket. We're just going to add all of this up. Okay, so there, and here I've put all the formulas for you because I'm so kind. So here we have added all of this up now. Okay, now we realize that this model is not that good. Okay, so if we go look at what we did here without the costs, if we go a couple of, what the heck, why does this not want to do what I wanted to do? But you know, this model is pretty crap. Because if we're going to go check down here by the BREEAMs, the purchase, if we look at the probability, this purchase has a 62% chance of being a BREEAM. This is not working. So and this is not working because we have not applied gradient descent. We haven't optimized. Remember that in all of these ML models, this is our first initial guess. And in truth, I show you guys how to pass in your OLS score because it gives you a good starting point. But you could also put in zeros because you'll see when you learn logistic regression from scratch in the second semester, don't freak out, you actually initiate with zeros. Anyway, so we want to fix this. So to do that, we're going to use the solver. So I've showed the solver in the videos for you guys for linear regression. Who can tell me what that solver did? What did the solver did in the OLS? Oh, no, man, the Ridge and Lasso videos. What did that solver do to the slope and intercept? Did you guys not watch them? I had to record them twice because there was no sound. Okay, let's go look what the solver does. Elise, where? The p-value, we're going to look at the p-value at the end. Okay. All right. So what the solver does is if you don't know how to put in the solver, you're going to go to File, Options in Excel. Okay, you're going to go to Add-ins. You're going to say Manage Excel Add-ins and click Go. You're going to make sure you click the solver add-in here, and then the solver will appear under Data, and your solver will be under there. Okay, so how do we apply the solver? When we click on the solver, it's going to ask us, which value do you want to optimize? Well, we want to optimize this value. Okay, then what do we need to change? What does gradient descent change? Well, it changes the slope and intercept as we go. So we want to change these ones.
Oh wait, so the solver is our tool for gradient descent.
It's our Excel tool, so you can see.
Oh, then it shrinks it. It shrinks the Ridge and
it shrinks it. So we are doing GRC nonlinear, and you can actually go in here and say how many iterations you want this to run for. We're going to say 5,000. Okay. And then we're going to say solve, and we're going to get a fact error. It is going to make changes anyway, but it's going to tell you it had an error, and that's why I didn't move away from this data set. Okay. So remember that you don't have to do this for your assessment, but do you see that your slope and intercept has changed? Because this has done 500 iterations. But it's going to say it had some issue, and you're going to see here, oh dear, my spreadsheet is all buggered now. What has happened? The other thing is you can't undo this. That's why I copied it. But do you see how small these, okay, yeah, okay, breathe. So some of these then break. And the reason for that is, and I'm going to show you how to fix it, and I'm showing you because I care about you, not because you have to do it, okay? Because they will never give you a data set that does this in the assessment. This is just me showing you the reality of things. And you see a lot of values here are changing fast for the better. So what happens? And now we have, and we'll talk about if it's a big negative value and a small negative value. You see these big negative values for purchase are becoming very big. A big negative value means we had an incorrect prediction. Now this thing is much better because now the negative predictions for purchase are much higher than for BREEAMs. All right, and I've put the steps in here for you guys. All right, so why did I get that weird little solver error even though it did the job that it needed to do? So I'm going to show you here why that happens, and I left the formulas out for you. Because we're hitting zeros and it doesn't like the zeros, but the numbers we are working with is very small. So you can actually just go pass a max into your likelihood formula to say you can have you cannot go smaller than 0.0001. Then it does the solver for you perfectly and you will get your new slope and intercept. And it will give you a nicely worked out thing where all of your likelihoods are different, everything looks better, and we have a much better classification. But in the end, and I think this one I have here only has breams. No, it has purchase. But in the end, a weight is not a good way to show the difference between a bream and a perch. And that's also the outcome of this model. But do you see how small it made the slope? And it made that intercept absolutely zero. So that's just what it does. This, I've just shown you if you ever hit the error value. It's not something you have to know. It's not something you're going to get assessed on. You also will very rarely do this in Excel. But if you are practicing and that happens, that's just how you solve it. It just doesn't like the zeros. Okay, and then it will update all of your data using the new values. Your regression score, everything will obviously use the updated values if you've done your spreadsheet correctly. Okay, so that then gives us this. We get that total. Then we go run that assembly line. Then we go say, adjust the parameters of M and B, optimize, recalculate, adjust the parameters, until we do this thing. Okay, and we get, well, model converges and we have a really good outcome. We're just going to have this slide here to remember why we are shoving it into sigmoid. And why we are shoving the linear equation into sigmoid is we need to account for negative affinity to positive affinity. So, in short, work out the OLS, shove it into sigmoid, work out your log likelihood, add them all together, apply the solver 9 million times until you get the best possible slope and intercept. How are you guys feeling? Yes, close to zero, Tumelu. Kat, yes?
So how do you, I know you were just thumb sucking there when you said do the reiteration 5,000 times. Is there like a live model that you can put on Excel to see whether or not you're getting as close as possible to zero? Or is that the point of the max of the 0.01 to prevent the model from going to infinity?
Yes, that's the point of the 0.01. Those are solver settings. Just remember, guys, that what I've shown you now is for understanding. In your assignment, you will never even configure the solver. I don't even think you apply the solver, and you will not configure the solver to the point that I've shown you. But it's good, Kat, that you're asking these questions because that will equate to your learning rates in your model, and that 5,000 will be your max iterations when you do this in Python. So when we talk about this model in Python, everything you've seen here in SMAA, you will see come into play. But Python is only doing exactly what we've done in Excel a million times faster and automatically fixing those zeros for us. We don't have to go edit our formula because it can do it for us. That's why we use Python for machine learning.
Thank you. It's helpful to understand how it works because I don't want to get to Python not getting it.
100%, and that's why you guys are doing this course, so that you can understand exactly how those algorithms work, because you're going to see those algorithms apply exactly this way in some systems will converge faster than others, but the solver will quit when it converges. It will stop. So I want to show you guys this. Okay, so you're going to see there in scikit-learn, logistic regression class has the max iter parameter. That's that 5,000 we just set. That controls the maximum number of training iterations for the, look at that, solver. But there's no explicit learning rate parameter because the default solver uses more advanced optimizations. Okay, so but that is set in Excel at 0.01 because it's not the solver in where's Serena's brain? It's not the solver as applied in Python. So there you can see there's that max iter. And you guys will see when we apply these kind of things, you will see that sometimes we have to come and increase the iterations because the model didn't converge. And then you'll see that there is also regularization. All of these things that we talk about will come into play. So just as you start, just remember that the reason that you guys are doing SMAA is that you can understand what you're doing in Python code and be a real data scientist and not be a code monkey, because anybody can write the code, but you have to understand. And this is also the knowledge that you need to have. Like after we've applied this, you have to go like, you know what? Between a bridge and a perm, weight is a terrible predictor. I should not use weight. I should use weight with something else or something like that. We can also apply this to that loan approval data set if you guys want to. Okay, so I think I have already broken this. What have I done here? Is there even formulas? Trina, what have you done to the sheet?
So Rena, when it's, I saw in your previous example, like I saw like a negative 0.66 or something.
Yeah.
Do you leave the answer in that format, or do you put it into a percentage to say, look, it's negative 60%, it's definitely not that? Like
You
how
leave
do you,
it
what? Yeah.
flat in that format. You leave it in that format because A, you're never going to do it this way. This
Yeah.
is just to show you. And B, people, you will see that over time, you will also read it in that
Okay.
format. You'll look for the negative values. So here is that loan income guy. Okay. And we have gone and we have gotten our intercepts and we've got our sigmoid value. And we've gone into our class implementation. So let's go and apply the log likelihood formula and apply the solver to this guy. So this is the summary output. I've just applied the data analysis tool pack. This I think is on Excel. And you will see here is your p-values. Whoever asked that question, the solver will always spit them out for you. Here is your quartiles, and your F statistic is right over there, and the significance of your F statistic is over there as well in your ANOVA table. So let's apply this one more time. Okay, so let's just go get that formula because, you know, I be old. It has been a lot of Thursday night teachings where I have to admit that I'm old and sometimes I forget my formulas. So let's just copy this guy over here and let's go apply it to this loan approval. And what I will do is I will upload a data set for you guys to practice on. So let's go work out our log likelihood. So here we know is our loan approved. That is our Y that we are working with. Okay. So we're going to say Y. Yeah, months. You know, I have to put an equal sign. Y times sigmoid times the log of sigmoid plus 1 minus Y times the log of, just check my formula, Nate, 1 minus that prediction. There is our log likelihood. No, wait, let me do this right. Be proud of me. Ta-da. There's our log likelihood. I'm just going to, thank you. I'm just going to insert some columns here so we have some space to work with. So let's just go find our MLE value. What is our MLE? Our MLE is just the sum of this.
You're doing it again.
I'm sorry. It's too late. I've committed. It's just the sum of this. So now we want to go and optimize for this. So now we're going to use the solver. So we're going to click on data. We're going to click on solver. We want to optimize this guy by changing these guys. Okay. I'm going to leave the options. I'm not going to set anything now. Let's see what happens if we say solve. The solver found a solution. This is a nice and clean data set. We're going to say keep the solver solution. It has changed your slope and intercept. And I'm in the wrong spreadsheet. It's fine. It has changed our slopes and intercepts. Actually, it has dropped some of our variables too close to 0, and it has minimized this for us. And this isn't a true 0. This is just an Excel contip with the small 0. But that is it. And remember, you guys, in this case, stuff will go, oh, and I can't undo this. This is how you apply it, but you won't be asked to apply it till this, to this point in your assessment, because you have to be, whoever set your assessment has to choose like the perfect data set to stop stuff like this from happening. Your assignment stops here at the sigmoid column. I'm going to go double check for you, but for you to say you stop here, you need to understand MLE, and you need to understand log likelihood and how we solve for it conceptually. I show you the calculations, and boy, if we just broken this spreadsheet. I show you the calculations so you can have a really deep, clear understanding of what happens. Okay, I will find a very nice data set and record a short video to show you where the solver doesn't cause nanas like this. Okay, but it has reduced down that MLE, and there's very good reasons why these things are the same, because these things are all the same. Okay, and our sigmoid is 0.5, 0.5, 0.5. This is a horrible model because this one should not be 0.5. But yeah, and remember, you guys, that your models are very often horrible. This thing that you're just going to train a perfect model is not true. You train many times, you suffer quite a bit. And that's why in an introductory qualification like this, you guys are not ever penalized for the scores of your models in the PDAN module. Your model can score an accuracy of minus 555,000, which is impossible. But if you can tell me why, you can have full marks for that module. This is like not a, how can I put this? The why is important here. The what does it mean is important here. Are you guys okay? Yes, Aliziwe.
Hi, Serena. I just had a question with regards to the solver. I'm just trying to wrap my head around it. Do you mind showing like a graphical version, or like, I don't know, going through it again? I'm so sorry.
I love drawing ugly pictures in the whiteboard. Let's go. You know what the worst is? I actually have a very nice tablet with a stylus. I just need to plug in. And now it's my last smart class, and I don't have to do it again. Okay, so let's take one record here that we have not done horrible stuff to. Okay, so let's take this record and bring him here. And we're only going to look at the example of this guy. Why were you not paste? Never mind.
Remember, your classes and likelihoods are the wrong way around on this example.
Yeah, you're going to remind me many times, Nate.
Mm.
Yeah, so just keep telling me that if I'm being an honor head. Okay. Okay.
A quick shortcut for that is just Windows Shift and S.
Okay, listen, I told you
take a
guys, and
screenshot.
now it won't paste. Why? Okay. So let's just say that we came out here for this bream with a probability of 0.564. Okay, so we have done the things. We have taken the weight, and we have taken the height, and we have gone and we've applied OLS, and we've gotten initial, intercept, and slope. Okay. But then we go check and we're like, let's take one of the photo records actually. And then I'd like more Excel tips at the end of this course. So then let's go look at one of these guys where we go like, yeah, but we're actually very wrong because this is a perch. And this perch is coming out to 66% bream. So why did that happen? Okay, how do we fix it? Then we go and we apply the solver. And here is what the solver does. It does gradient descent for us. So the gradient descent calculations, you guys don't have to do manually, okay? However, I will record a video for you on gradient descent for understanding, but with the promise that you'll only watch it knowing you don't have to calculate it and not throw up, okay? So what we're going to do is we're going to go like, okay, so we are looking for this thing to say perch. It very, very much came out bream. Okay, how wrong were we? Well, we were 40% wrong. Okay, we stuffed up nicely. So how do I fix this? How do I get that value lower? So what does the solver do? The solver goes like, okay, well, what did I use to calculate whether this is a perch or a bream? Well, I used the slope and the intercept. So the only way to change the outcome, and that's what they mean about the chain rule when they talk about I almost said gravity descent when I talk about gradient descent, is that you have to unpack one formula to get to the other. So we can't just directly change the outcome. We have to go change the slope, and we have to change the intercept, and then we have to run the calculations again and like pop them up like Russian dolls, because right now our slope and our intercept is living inside our slope and our intercept, our OLS value lives inside our slope and our intercept. So we have to pop them open, and we then have to change the variables in them. That's what's known as the chain rule, where one formula lives in another. So there's a formula to calculate the slope. There's a formula to calculate an intercept. Those two formulas live inside the formula to calculate OLS. And the OLS formula lives inside the formula to calculate sigmoid. So to work our way back, we have to pop those guys open till we get right to these two calculations to edit these two values. So the solver will first make a big change. And it will go like, my intercept was 0.1 and my slope was 0.3. So I'm going to make quite a big change, okay? I'm going to make my intercept 0.8 and I'm going to make my slope 1. Then it's going to go do all the calculations again, and it's going to say, what do you come out as now? And you're going to see that in of these examples, every calculation changes with those new values. Okay, look at the likelihood here. Look at the incorrectly calculated likelihood over here. Oh, where is the likelihood, Serena? Where did you do the likelihood? See what the likelihood is here? Look what the likelihood is after we applied the solver. They are much different. Okay, so that happens because we make these changes, and then we go and we do our first iteration and we calculate and we say, okay, what does this thing say now? Oh, crap it, man. Now it's saying it is 50%. We were at 60%. Now it's saying 55%. It's still not sure. So that was one iteration of the solver. And remember, we just ran 5,000. Okay, so it's still not sure if this thing is a perch or a bream. Okay, so I have to change these again. So back I go, I unpop all of those formulas. I apply the chain rule to get inside all of the inside formulas. I come out and I go like, right, now the slope is 1, or the intercept is 1, and that slope is 1.5. And I make another big change. But then as I get closer and closer, now it comes out at 50%. I go like, oh, I must make smaller and smaller changes. I can't keep making massive changes. I'll overshoot in the wrong direction. So we keep adjusting those slopes and intercepts. And that's what the solver is doing. It keeps adjusting them in increments, 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 increments. And this will keep going. Okay, now I am 60% sure this is a birch and not a bream. Now I am 70% sure. It keeps going, 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 it keeps adjusting these guys like this with every single iteration until it gets here where it goes like, I'm 98% sure. Make a change. Oh, I'm 98% sure. 98.1% sure. Make a small change. Oh, now I'm 98% sure again. Make a small change. Oh, now I'm 88% too, but nothing massive changes. The changes here is so small that it won't change the outcome of the model. That is when we end up here at the bottom of this convex curve and gradient descent, and we say the model has converged. When we gave that solver 5,000 iterations, we told them, here's 5,000 chances for you to change the slope and intercept. It will stop when it converges, and it will tell you if it didn't have enough iterations to not converge. But it stopped very quickly there. We didn't even apply, I want to say 200, when it was like, okay, look, this is the best that this model is going to do. Your solver applies gradient descent. It applies the optimization function to get the best possible model. Did that help?
That was perfect. Thank you so much.
Okay. And that was it for tonight. That was the last bit you guys had to do, because I kept you last time till 9:30 when I saw the time and you were broken, and I'm sorry. But that is, and now Is this still as complicated as the first time you saw this? When you saw this last week, you were like, oh my God, I'm going to die. I can't do statistics. I have math dumb. And now you're like, oh, I see it. And I said this to you at the end of the linear regression class. The only thing that changed between last week and this week is repetition. So just look at it again and again, and it will percolate into your head. Okay, but now you guys can do 3 distinct ML algorithms. You understand k-nearest neighbors, linear regression, and logistic regression. You have a good understanding of evaluations, loss functions, and optimizations. Goodly, you are done with logistic regression. Dansky. And like I told you in your assignment, you're not even going to apply the solver. It's not going to take you that far. Sisetu?
Hi, Serena. I'm having a look on ARC, and I see that we also have ICE tasks, which are all due on the 3rd of May. Is this correct? And
no.
Okay, so it's only the assignments that we are doing, formative 1 and formative 2.
You guys will have ICE tasks. I will reach out to Daryl. So I am not the module owner. I'm just, so you remember that SMAA is being taught in a masterclass fashion, meaning people who are really comfortable in certain algorithms are teaching them to you. So the class owner is Daryl. I think you guys met Daryl on the first day. So Daryl is responsible for ICE tasks. I will reach out to Daryl and I will ask him how he wants to set the ICE tasks. There is also not always 4 ICE tasks. When it is my module, like in PDAN, I generally give 2 ICE tasks. Maybe 1, because I don't like smaller ICE tasks. If I'm going to ask you to work, it's going to have to be meaningful. So I'll talk to Daryl and ask him how many ICE tasks he wants and what he wants covered. And ICE tasks are due throughout the semester. And ICE stands for Integrated Curriculum Engagement. It is supposed to entice students to think about the material. You cannot get it wrong. You cannot get 0 for ICE. The only way to get 0 is to not do it. Yes, Nazreen.
Hi, Serena. I don't know if this question was asked already, but for assignment 1 on the past schedule, it says like the due date is between the 30th of March, I think, to the 2nd of April. Does that mean like we have to submit within that time frame or on those specific days?
Yes. So for postgraduate students, we give you guys flexibility in submission. So you will get, okay, I see the ICE task problem. You will get a whole week to submit in. So you can submit from the 30th up until the 2nd. We don't give you just one submission date because you have jobs and things happen and you're grown people now. So we give you a week to submit in. So you can submit anytime during that week, but the cut-off date is the 2nd of April. And you can do multiple submissions, and we'll always mark the latest submission unless you leave us a note to instruct us otherwise. Kamugelu?
Just a reminder with the slides for this lesson.
I'm going to stick those slides up here now, but I'm also just going to stick them on WhatsApp in the interim. I'm not going to do that with my screen share because I have conversations with my family in WhatsApp. Yeah, you don't want to know about the dog and all of that stuff.
And the cotton on.
Yeah, the cotton on. Yeah, the cotton on hoodies is real expensive. Yeah, Tabisa, what's up?
Yeah, those ICE tasks, I did have a look at them earlier on. They're like 5 questions, multiple choice questions. I went through 2 of them. Already.
So they gave you nice
there are like 5 of them. It's 5 questions that relates to KNNs, 5 questions that relates to linear regression, 5 questions for, I think the other one was the GEM or something like that. The GEM.
GAMS, yeah.
Yes, the GAMS. Yeah. So that one I left it out. I think it's ICE 4 up until we get to to that section.
So we did everything for ICE 1, 2, and 3 already.
Yes, yeah, it's all 4 of them, but then I think the first 2 it's things that we've already touched on when I looked at it and when I went through of them, and they gave you I think 5 attempts to to go through them. Yeah, and by the way, By the way,
Yeah.
as we wait for Kat to give us another Excel shortcut tips. So
Yeah, we like Excel shortcut tips. Keep sharing those. Listen, guys, my advice to you would be like, those are nice, easy, low maintenance ice tasks. Keep them, do them. I'll ask about the due date, but keep those like soft ice tasks. Okay, get that 10%. If you want more examples of stuff to work through, we'll happily upload them for you. But I think if those are short multiple choice ice tasks and they're low maintenance, just keep them. Danica can't see the ice tasks. Somebody tell Danica how to find the ice tasks, because I don't do ice tasks anymore. I'm
on
like,
the announcements, if you go to the announcements on the
yeah, you can also copy and paste the link there for you guys. You can copy and paste the web link, and then they're easy to find. Bianca can view them. Okay, so guys, help a friend and share the link. Yeah, so on that note, you guys, this was my last class with you. I don't see you unless for PDAN. You'll have me on Thursday for PDAN, and you'll have me for PDAN throughout the whole semester, except for one class in April where I'm doing some field work in Namibia. And normally if I do international field work, I teach you from the country I'm in, but in Namibia, I'm in an area called Ochisa and Kunene where there's no signal. So Nadia will take that session with you guys. I think it's support vector machines. But for the rest, you have me. But this was me for SMAA. You guys will see Daryl next week for GAMS. Thanks for being a great class. Kat, thank you so much for the Excel lessons. I will definitely ping you when I have more questions. And you guys are in great hands with Daryl. You're in great hands with everybody else. The tone of the lecture stays the same. The structure of support stays the same. You have Gareth and Nadia throughout. You have Justin, who has joined as your tutor. And you guys must reach out to Justin because he was someone that was very averse when he started, and he got 98% in the end. Okay. Yes, Sethu, last question.
Last question. Just to clarify, is there an exam for this course? And also, do we get information regarding what the tutorial will cover so that we know
Good
before
question.
the time?
So you guys, the structure of this course is 2 assignments and a summative assessment. So a summative assessment is like a project. You do not have an exam. You have but I don't know if it's timed or not. I'll go check for you, but you have a summative assessment, which means basically one big assignment. No, you also get a week to do it in. You have one big assignment, okay, that you have to do. Nothing closed books for statistics whatsoever, and all of it's done in Excel. That was the one question. And then you had another question, which I've got. Oh, the tutorials. Generally, the tutorials is that tonight you've done logistic. Oh, my word, sorry. Tonight you've done logistic regression with me. And then you will do logistic regression with Nadia again in the tutorial session. And then Josip, listen, Josip is Justin, but to me, he gets to be Josip forever. Justin will run a session. So Gareth gives general support. So you guys saw Gareth on Saturday, the T test, F tests, P tests, all of that kind of stuff. Gareth is your guy for general support. In general, the math is not mathing. Okay, Nadia does repetition tutorials on what we've done in class, and she'll either work through a different example with you guys, a more complex or a simpler example. And then Justin does both. He does general math, he does assistance for the stuff we've done in class, and we run 2 different tutorials because you have a job and you can't always make the one, so there's the option of the other. And Josip is who you find when you're having emotional implosions about this course and you go like, I can't do stats, why did I register for this, blah 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 blah. Then you find Justin, because Justin started this course so nervous, and at the end when I marked his assessment, I was like, why are you even nervous, what's wrong with you? So he's someone who can take you from panicky to calm. Those are your support people. Kat, I was wondering if we can talk to you about maybe running a general Excel session. Tutorials are paid for. You get paid to deliver them. It's not free service, but I don't know how much. To run a nice general Excel session tutorial for everybody, that would be very nice. Would you be keen? I would also like to attend.
Sure, I don't mind. I wasn't actually asking for you to pay me. That was a joke. But if you're gonna offer me money, Ford Ranger coming up, yeah, let's do it.
You don't give your skills away for free. What are you talking about?
Keep your target on the Range Rover, kid. Keep it there. Keep locked there. Don't move from that Range Rover.
I currently drive a City Golf, dude. I'm tired of no aircon. I'm sorry.
You see, no. Then don't give your skills away for free. Tutorials are paid for. Next year, you guys also have the option to service TAs. Nothing is for Mahala.
Sure, but today, if you wanted to see at the end, this one's quick. You'd need more time with me in a proper lesson, but I can show you how to do a VLOOKUP and a pivot.
So I'm okay with VLOOKUP and HLOOKUP. Does anybody in class want to see a VLOOKUP and an HLOOKUP? Go ahead, Kat. Share your screen. Show us.
Okay, let's do this. Forgive me here. I just want to use a whole new data set because VLOOKUPs, they use two data points.
Okay. I used to do that back in the dark days before Python. Andrew, your hand is up.
Sorry, I just wanted to recommend something that sometimes when you're teaching them the X and the V, it's probably just better to like teach them the V and the H. It's probably just better to teach them the X lookup at once because it's just a lot more holistic.
People, I don't even know what an X lookup is, man. But
It's like the easier version.
It's much quicker. The reason why I wanted to show a VLOOKUP is because VLOOKUPs, again, is like Serena explained. If you understand how to do the difficult one, you understand the why, and then you can plug in X lookups into anything.
Okay, well, let's go. We are having a quick masterclass in VLOOKUPs and HLOOKUPs.
Okay, so like, for example, this is my typical data set that I work on. This is our company's stock on hand report, since Coty owns like a bunch of really high profile brands. So each, like when you go to a retailer or a store and you want to buy a Gucci perfume, that individual perfume is a SKU, and we have thousands of them. So it's really difficult to nail down exactly what you want out of a data set if you don't even know what you're looking for. So I'll do this. For example, I'll do a, let me export this piece of data. So I'll go to our report thing on Power BI, and let's say I want to get specific data around what's happening in week 9 of 2026.
Okay, show us.
So we'll start there. I'm opening that data quickly, if this will play with me. And I want to add something called pillars, which isn't currently available in this data, which I need to get from our stock on hand report. So how I add pillars is like this. It's there. And then I want to find the linking barcode from this set of data and the second piece, which would be the stock on hand report. So this barcode here, and if I go back to the other file, this barcode here, they are the same thing. So I want to get this piece of information from the other file. It's called the pillar, which isn't present in the file I'm looking for. So I want to move all of this from here to the other file, but I want to match them with the appropriate barcodes. So if you did something like that manually, it would take you like 3 years to just go through one file, which is why we do VLOOKUPs. So what I do here would be, now to start the formula, I would go equals, and then I want the link or the anchor between the two files, which is these two things which are the same. And I want to highlight the entire column. And then I put comma, depending on what your VLOOKUP says. And then for me, it wants the table array. So the set of data which encapsulates the barcode and what I'm looking for in this information. So the table array for this, I'll start at the barcode all the way up to the pillar. So it will say there, as you can see on the screen, is that 104 times 21C. Are you still following?
Yeah, I am.
Okay, cool. So that 21C is important because that 21C is, that 21 number is the number of columns from the barcode. So you have to remember that number. So if I go from the barcode all the way to the pillar. So if I highlight everything there, I say 21C, I highlight it. and then I go back to the other one. And since I want the exact number, I will lock it. And then I put a comma, and then just do this. I've never taught this on a screen online.
I'm sorry, but that's the best way to learn.
Yeah, let me do this again, right? I'm putting the wrong reports in the wrong place. So I want to put the main one that you guys are seeing my equation on, and then put the second one on the side because I have two screens here. To move this thing here. Sorry, apologies, guys.
No stress.
Okay, so let me just do that one again quickly. Go feed of that. Look up value. Table array. I'm doing the other one on the other screen, but I just want you to remember that I went to what I did previously on the other step.
Sorry, Kat, maybe a stupid question, but
no such thing.
Why are we highlighting the whole of column D? Aren't we just looking up D2, for example? We just want the value of D2, and then we can copy that.
Okay, let me point this out then. You see, this particular barcode, okay, let's say we want sport women. This particular barcode isn't in the same position on the other file. Remember, when you're working with masses of data, it could be on position 1030, but on this file, it's on position 4. So how are you going to move everything over in one go if you have to find the individual barcode on both files before you copy and paste? Now, I'm asking, if you have another way.
Okay, wait, maybe just do it quickly. I just want to see something because we are basically saying now we are looking up column D. So the whole of column D, we are looking up against the other table.
Yes.
But why aren't we just saying we are looking up D2? So we want the value, so D2. What is the pillar in the other table? So we would say we look up D2, go to the table 21 because we look at column 21.
Yes.
And false.
The reason I do this is because I want to, if you're following along here, I want to generate all of the pillars for every individual line, which I just did now. And the VLOOKUP formula can hold across the entire set of the data. So if I did it one by one, I wouldn't finish anytime soon, but now I did it quickly. And the advantage of that is if I want to take this piece of data and quickly pop it into a pivot table, I can do that now quickly because I did that VLOOKUP formula.
Nelson has a question.
Yes, please.
It's not necessarily a question, just let's say I don't think that's much difference from what you guys are actually discussing. Whether you select one cell or you select the entire column, it's gonna give you the same result because you are actually telling Excel that for an example, if you're gonna select one cell in a column, you're telling Excel that go to a particular sheet and look for this barcode in different sheet and bring that particular information into this sheet, you know.
No, yeah,
and
it's
if you are
this. She's
selecting
right.
the entire, if you select the entire column, you're still telling Excel the same thing, that from D1 to D2, go look for these particular barcodes in a particular, it's basically the same thing.
Yeah, like, so if I did it this way, I would get the same answer, but I have to lock the equation. Because if I lock it, then it will find me the pillars for each individual barcode. But if I did it for the column, even if I make an error, I don't have to lock because it's finding for everything in that column. So if you do it for each individual like barcode like this, which I'll show you, what she's saying is correct, it will work. I just need to make sure my formula is correct. Like there's less room for error. I don't know if that makes sense. Let me do one. Almost done. So I'm doing it just as you said now, Bianca.
Thomas is asking you if this is a full outer join in SQL. That's a good question. It's an outer and an inner join. I think, Promise, that I can't even remember joins in SQL that well.
Look, it works. So same thing as if you're doing one cell individually. But that's because I locked the form here. Wait, where was it? There's a point where I put the $sign, and that's why it allows me to populate for everything. But if I didn't do the $sign, everything would be not applicable. The format would be broken.
Yeah, because your references will break.
The reason why it's useful is because when you put it into a pivot table, I can quickly see what the hell is happening for each retailer. So for example, quickly, let me just show you how you can go through data that quickly. So you can see how each brand is like doing in the given retailer.
So yes, that was very helpful. I think what we need to do is at the end of next week's class, someone needs to demonstrate XLOOKUP. I will tell Daryl. Yeah. Someone needs to demonstrate XLOOKUP. And is there any, so why not use Access instead of Excel? Well, you should use SQL, but a lot of companies use Excel for their data. Yeah, so you're saying why not just run a query in Access? But lots of, so when I started working for EMERIS, I was super annoyed that the financial director had a very, very strong laptop. And I went to the IT guy and I was like, what the hell is this? I train ML models. What does this man have? Like a stallion, and you've got me on like a hip hopping pony over here. And he was like, have you seen that man's spreadsheet? So lots of companies that work, including us, our financial director also did all his stuff in spreadsheets, needing enough RAM to like run quite a vicious machine. Okay. So did you guys do a VLOOKUP in, you could do a VLOOKUP for the KNN model. Did you guys do a VLOOKUP to find the value for iris, or was it just, it's too small? Okay. Anyway, to be like what flower it is.
I did. Yeah, there's a tutorial I found on YouTube that kind of works, primarily does the whole KNN thing on Excel, and he uses VLOOKUPs to find his data.
Find his data. Okay. Perfect. So at the end of the next class, I will tell Daryl, I will join in. We're going to take a look at XLOOKUP. More pivot tables would be really cool. And if anybody works in VBA, yes. All right. Thank you, Kat. I will definitely we'll look at some pivot tables. It's been might make my life easier. Yeah. Do you guys have any final questions? Okay. Then you know where to find me on SMS. No, Serena, that's like the 90s phone. You know where to find me on WhatsApp. If you have questions, please reach out to me. You can also find me on Teams. Good luck for your assignment. I'll be marking the linear regression portion of your assignment for my sons. And then you guys will have Daryl for GAMS, and then you have Nadia back for a bit. Trees is Prof. Sheetal Tom. You're very lucky to have her. She's such a wonderful person, such a wonderful lecturer. Then you'll have Daryl again for ANNs, and then you'll have Nadia for PCA, and you'll end with Daryl. And you'll have one session with a lecturer called Richard, who is from the Namibian University of Science and Technology, who is also a very good statistician, and he will take you guys through, I want to say, dimensionality reduction techniques, like NMF. So these are the things to expect. Expect Daryl, then a small shift to Nadia, back to Daryl, small shift to Sheetal, and then a small shift to Richard, and ending off with Daryl. Okay. It was a pleasure teaching you guys. I will see you on Thursday for PDAN. We will code up the whole linear regression fully so that you guys can have linear regression waxed. All right, now go have a lovely evening. Go to bed a bit earlier because I kept you so late last week. Okay. Yes, Kat.
Oh, sorry, I was trying to react.
Oh, no, no worries. Okay. Good luck, guys, and enjoy statistics. It's not difficult. Okay. Bye, guys.
Thank you. Bye, Serena. Bye, guys.